planets in the solar system apart from Earth. One in particular carries a stark warning about what happens when environmental dynamics run out of control. Inappropriately named for the ancient goddess of love, Venus is an unfriendly world permanently clouded by a dense carbon dioxide atmosphere. None of its surface features are visible through a conventional telescope. Radar scans reveal energetic volcanism and mountains deformed by heat. The atmosphere traps heat from the sun so that a runaway greenhouse effect has taken hold, making this a hellish place where ground temperatures are high enough to melt lead. In December 1970, Soviet Russia achieved a successful landing of a robotic spacecraft on Venus. The lander survived for about 20 minutes before succumbing to the intense heat and pressure, but it lasted just long enough to send the first pictures ever taken on the surface of another planet. In visible light, Venus appears as a featureless sphere, similar in size to the Earth. The planet's surface is entirely obscured by a thick atmosphere of carbon dioxide. This seemingly calm gaseous shell veils a world of hellish temperatures and nightmarish landscapes, swathed in clouds of sulfuric acid. While previous probes had sent back black and white photos, the first colour pictures of the Venusian surface were transmitted to Earth by Russia's Venera 13 robotic lander in 1982. Flat rocks are scattered on a dark soil amidst a volcanic landscape. The probe survived for just 2 hours before the hostile surface conditions disabled it. In the early 1990s, NASA's Magellan space probe penetrated the atmosphere of Venus with radar instruments, gradually building up a height map of the surface terrain, including large mountains. This radar image shows the Mart Mons volcano. Its peak is covered by rough lava flows that wind like rivers across the surrounding lowlands of older and smoother terrain. Venus is named after the Roman goddess responsible for matters of love. But nothing could be less lovely than this world, with its surface shaped by volcanoes, lava flows, and the corrosive effect of its noxious acid-misted atmosphere. The next few images are hemispheric visualizations compiled from 10 years worth of data from different space probes and radar instruments. In this image, a view centered at 270 degrees east longitude shows the purple areas representing the lowest lying regions of the crust, as measured from the center of the planet. The bright white area in this image is directly above the planet's north pole. It is known as Maxwell Mons and is the highest mountain on Venus. And here we have a mosaic centered at 180 degrees east longitude and shows the volcanic nature of the forces shaping the crust. Venus rotates around its axis once every 243 Earth days, and its rotation is retrograde, meaning from east to west. the opposite of the prevailing trend in the rest of the solar system. Radar mapping makes these pancake-like features look like craters, but they are actually raised blisters, approximately 65 kilometers or 40 miles across. They formed when thick lava flowed through vents under the crust and set in place before the deformations could settle back to their original heights. Other features, such as this appropriately named arachnoid, are circular fractures created as underlying lava forced the crust upwards, cracking it to patterns like spiders' webs. Coronae, sunken areas surrounded by roughly concentric rings, are formed in a similar process of crustal swelling and collapse. This view westwards towards the slopes of Maxwell's Mont shows details of the tallest mountain on Venus. The dent-like feature on the slopes of Maxwell is the impact crater Cleopatra. Perspective computer-generated view, based on radar measurements, shows part of the lowland plains in Sedna Planitia. The circular depressions are coronae, which are apparently unique to the lowlands of Venus. Coronae tend to cluster in rows along the edges of the planet's major tectonic belts. The large sections of crust that float on top of the underlying magma, somewhat like the Earth's great continental plates. Vortices of gas whirl around the polar regions of Venus, shaped by the planet's rotational energy. High-altitude gas from the equatorial region travels towards the poles, where it loses some of its heat and sinks back into the lower levels of the atmosphere. Similar, if much milder, processes shape the weather on Earth. And that concludes this episode of Wonders of the Universe, which of course covered Venus. The next planet in our series is going to be Earth, and if you are finding this at all useful, do please hit the like button, please subscribe to the channel, and if you hit the notification bell, you'll be alerted every time we upload something new. Thank you very much for watching. Hope to see you in the next one.